Well, it's time to put it all together. We are now going to handle our tangent, cotangent, secant, cosecant functions, and we are going to put together with the final movement, which is time shifting. And we're going to start off pretty easy in this example and the next one, because we're only going to introduce a few movements at a time. Now, we want to kind of highlight what we talked about earlier in the sine and cosine phase shifting videos. I won't be going into it as in-depth as I did in those, so if you haven't watched the sine and cosine phase shifting video, this is one you're definitely going to want to watch. So here we have bx minus c. Now this minus c indicates the phase shift. In some books this c is the Greek letter phi, but in this book it's as a letter c. Now the subtraction means that we're going to go to the right. So subtraction means right, and addition means left. And I really went in depth into that in a previous video where we dealt with the sine and cosine phase shifting. So please just remember that subtracting moves it to the right, and it's then going to be a positive value on my phase shift. And if I have a plus, then it shifts it to the left, which makes it negative. It's opposite the way you see it. Now, there are two very important formulas. When dealing with a period adjustment, so the letter B, your period formulas are going to be basically depending on what trig function you have. If you have sine, cosine, secant, or cosecant, your period formula is 2 pi divided by absolute value of b. Or if you have tangent or cotangent, it's just going to be pi divided by absolute value of b. We don't really need to worry about the absolute value signs because we would handle a negative b value just by using properties of odd-even functions. Now, there is also the phase shift function as well. If you have a letter c that isn't a 0, the phase shift function is always c divided by b. And again, we're not going to concern ourselves with the fact that it's the absolute value of b, because our b values in all these examples, including the one in the book and on the test, are all positive. Because if they're not negative, if they're not positive, we would handle them with an odd-even function. So let's kind of take care of this first example, the first of two examples in this video. Let's handle this first example, and we're going to shift this to the left. And we're also going to, even though it's trivial, do our phase shift formula, just because we should get into the pattern of that. Because it's going to be very easy to make a mistake and just look at this fraction and say, oh, that must be the phase shift, but we have to take into account if there's any period modifiers. So let's get our asymptote lines together for the tangent function, which is here and here. Our tangent function starts at the origin and goes to 1 at pi over 4. And since there is no period adjustment here, I'm going to feel pretty solid in putting in my pi over 4. And this is going to be my asymptote line here at x equals pi over 2. Okay, so going to continue on right here with this point. We're going to have a low, a medium, and high. So this is going to curve downwards, and this is going to curve upwards. All right, so and then this continues on from here, low and medium, and this ends here, since this is pi right here, this is going to end here at 2 pi. So the points then indicate what we need. So we are now all ready to rock the amplitude, which is 1 and -1. So we report our amplitude as 1. We didn't have any period adjustment at all since this was a 1 value here, so the period is going to be just pi. As you can see that this graph kind of starts here, swoops up. This is the end of one period, and then if I switch to green, here's the start of the second period. So the yellow represents one period, the green represents the second period. Now, there was no vertical shifting, so our midline is y equals 0, or the x-axis. And I guess what's kind of cool about this is we should probably now take a look at our actual shifting of this problem, which means that I'm going to have to get rid of this point because this whole thing is going to shift to the left by pi over 2. Now pi over 2 is right here on my x-axis. Now pi over 2 is the left shift, so everything that's from this point is going to get shifted 2 tick marks So 1, 2 tick marks to the left, because that is how far away pi over 2 is from 0. So now the asymptote line gets put here. This swoop that goes from pi downward is going to get shifted 2 tick marks to the left. So this dot gets moved to pi over 4. And this point here is going to get moved over here. Okay, so there it is. There's my swoop of this yellow piece. This yellow piece is now here, and just so you can see it, there you go. So that yellow piece is here, and now this green piece is going to be put here, from 0 up to here, and then this asymptote line. So this is now this little green section. So to see how the green section moved 2 to the left, and now we're going to have another green section go like this. All right. There you go. So there's, oops, I'm a little off my point there at -1. Whoops, that's at 1 there. Let me just make a little fix. Okay, cool. All right. So you can now see how my yellow piece got moved 2 tick marks to the left. The green pieces got moved tick marks to the left, and so did the asymptote lines. And then finally what we have is this missing piece, because we have to, by the rules of my test, you have to put 2 full periods in there. So this now finished my 2 full periods of my tangent line. Now you can see that my period is pi, and my phase shift was pi over 2. And you can see that I didn't actually concern myself with the period, because pi over 2, or c divided by b, is just equal to c, or just pi over 2. So it was easy to do the shift because I had no period modifier. So this is going to be negative pi over 2, or you could write it as pi over 2 to the left. Okay, so that's just one of 2 ways you could do it. So now my range is still going to be all real numbers, because I can go from -infinity to +infinity on my y. I can plug in my points, and my points here, I think it's handy to kind of like write out my x-axis. So this is going to be x equals 0 right there. That is going to be my first asymptote line. Here I have my point at pi, comma 4, comma -1. I'm going to have another asymptote line here. And I'm just going to skip ahead a little bit because I could. Well, let me just do this one here. That's at pi over 2. So it looks like pi over 2 comma 0. And let me skip ahead a little bit. It looks like I want to go here. So this is going to be pi. So this is the equation x equals pi. Don't forget that your asymptote lines have to have equals little signs on them. And then finally, we're going to get to the very, very end here, and we're going to have, I can pick this asymptote line if I want to, x equals 2 pi. And again, as long as you have 5 points or asymptote lines, you should be okay. Just try not to have 5 asymptote lines. That is a bit much. Okay, so that was pretty straightforward. Again, one of the dangers that I almost ran into is I counted this pi over 2 as my phase shift without checking for the period, but luckily the period was equal to 1, so I didn't get into a problem there. All right, let's be a little bit more careful, because this next problem is going to get a little bit more harrowing, and this is going to be the end of this video. And I wrote multiple graphs so you could have space to write it if you needed to, but what I'm going to do is I'm going to use this little space up here in the corner and rewrite my function. Y equals 1/2 cotangent 2x minus pi over 2. Okay, so the letters A, B, C, D that the book gives you, instead of the Greek letters alpha, omega, and phi, and beta, the reason why I like A, B, C, D is because that kind of gives you the order in which you should do the problem. Like, we are first of all going to draw our cotangent, so let's put our asymptote lines in here. And then cotangent is a high, medium, low pattern, such as so, right there, down here. Here's another dot, and I'm going to go, whoops, I was a little off there. Oh, I'm way off, excuse me. There we go. So we're going to have high, medium, low. There's the high one, and there's the low one. Awesome. Now, the first thing we should do is letter A, which is our amplitude. So this is going to be 1/2 and -1/2, which is 0. What's cool about that, the amplitude is going to be our 1/2. We always report amplitude as the absolute value. Our midline is y equals 0, and vertical shift is 0 because our d is really +0. Even though we would technically do that last, I just got it out of the way. So now let's deal with the period. Because normally the period would then be right here, it would be pi. But let's go to our period formula. Our period formula for tangent and cotangent is pi divided by the absolute value of b. And in this case, our b value is 2, so this is going to be pi divided by the absolute value of 2, so our period is pi over 2. So we can now put in our x values at pi over 2, and I'm going to do so cleanly here. I got pi over 2, which means that this is going to be half of that, which is pi over 4, and then half of that is going to be pi over 8. So if this 1 pi over 8, then this is 2 pi over 8, 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, 6 pi over 8, which is 6 reduced by 8, that would be 3 pi. Let me think here. Yep, 3 pi over 4. And then we got 7 pi over 8. And then we have 8 pi over 8, which is just pi. Okay, so that right there is my period and my new x-axis. Now what I need to do is check out my phase shift. Now my phase shift is going to be c divided by b. And in this case, my c is pi over 2. And in this case, my b, if I divide by b, my b is 2. Now dividing fractions, please don't cry. Skip the first fraction, flip the second one, so in this case of it being 2, it's now 1/2, and then this makes pi over 4. Alright, so I got pi over 4 here. So what I get to do is I get to shift everything to the right by pi over 4. So this is a situation where you take a look at this value is not your phase shift. This is a phase shift modifier. The reason why in the previous problem this matched our phase shift is because our period was 1. But in this case, we have to now take this phase shift of pi over 4, and we're going to move 2 tick marks to the right. Now the reason why we're moving 2 tick marks to the right is because our pi over 4 is 2 tick marks away. So everything is going to get moved 2 tick marks to the right. So this asymptote line gets moved 2 tick marks to the right. Here's our new asymptote line. Then this gets moved 2 to the right, so this starts high, and this medium dot gets moved 2 to the right, so this goes medium, and the pattern continues low. And then we have another asymptote line in here. Curves up like so, curves down like so. So there it is, high, medium, low. And the pattern will continue. So you can see now I've taken this yellow line and moved it here. So now it's time to bring the rest into play, because if this goes high, medium, low, then this is going to be high up here to medium, like so. And then this high and medium would have to be continued here to medium and low, and this would be my final answer for this problem. Now you might say, like, wow, this looks exactly like tangent, but it's actually not. In fact, the tangent line moves up instead of moves down, so this is not the same. But what's important now is that we highlight the range, which is all real numbers, or I could have put down instead the interval notation, and the interval notation here would be from -infinity to infinity, like that, with parentheses, like so. So, how are we going to handle domain? Well, let's label our points, and most importantly the asymptote lines, and see what we have. Of course, the origin's the easiest one to plot right there, and then maybe pi over 8, comma, -1/2. Okay, since our y values haven't changed at all. Alright, so that's -1/2, 0, and 1/2. So let's look at that first asymptote line. This is x is equal to pi over 4. Looks like my next asymptote line is going to be x is equal to 3 pi over 4. And if that pattern continues, it looks like the one after that is going to be 5 pi over 4, and then 7 pi over 4. So essentially my domain is going to be x where we cannot have k pi over 4, and k is odd. And I don't have to write down odd integer because I'm going to assume when we're talking about odds, we're defaulting to odd integer. And finally, we just need one more pretty point. Let's see, which one are we going to take? Let's do 5 pi over 8, because that has a negative y value here, so negative 1/2. All right, so there are, this is 2 examples of handling a phase shift with a cotangent graph, and we're going to see in the next video here, we're going to see secants and another tangent graph where we're going to handle our phase shifting. So thank you very much for watching.